This is a practice paper for the Edexcel higher tier calculator papers. I will put a link to the paper in the description, and for each question there's going to be a similar question first, then you can pause the video and try the question from the practice paper. So let's get started. Question 1. The table shows the probabilities that a biased dice will land on 2, on 3, on 4, on 5, and on 6. And Neymar rolls the biased dice 200 times. We need to work out an estimate for the total number of times the dice will land on 1 or 3. So in the table, 1 is missing. We don't know the probability of landing on a 1, but we can work it out because all probabilities of everything that can happen have to add up to one whole. So if we do 1 minus all of the probabilities that we have, we'll get the probability of a 1. So we just type that into the calculator. And we get 31 over 100, or 0.31. So that's the probability of getting a 1. We want a 1 or a 3. So a 1 or a 3. When it's or, when you can have either 1 or 3, you add the probabilities together. So 0.31 and 0.18 added together makes 0.49. So that's the probability of getting a 1 or a 3. If we roll the dice 200 times, how many do we think we'll get? How many 1s or 3s? So the probability times the number of trials, 0.49 times 200 is 98. So 98 times. And one for you to try. So pause the video and give it a go. So this time the table shows the probabilities that a biased dice will land on 2, 3, 4, and 5. The probability it lands on 6 is 3 times the probability it lands on 1. So if 1 is x, 6 is 3 times as much, 3x. So let's find out what these missing probabilities are. And then Fred rolls the biased dice 200 times. We need to work out an estimate for the total number of times it lands on 6. So we need the probability of a 6. So just like last time, 1 minus all the probabilities that we have. And that will tell us the probability of a 1 or a 6. So 0.52. So x and 3x, which is 4x. 4x's must be 0.52. To find 1x, we can divide by 4. Which is 0.13, and 3x's, that's 3 times as much, 0.39. So x is 0.13, 3x is 0.39. So we're going to roll the dice 200 times. How many times do we think it will land on 6? So the probability times the number of trials is 78. question 2. Part A says complete the table of values. So we've got a quadratic. We know it's a quadratic because the highest power is 2. It's an x squared. So a quadratic graph, we need to complete the table of values for it. So for this, to find the y coordinates, I'm going to type the x bit into the calculator. So wherever I've got an x, I'm going to change it to brackets. So brackets squared minus 2 brackets plus 2. And I'll just type in the x value into the brackets, and that will tell me the y coordinate. So in the calculator, brackets squared minus 2 brackets plus 2. So wherever we had an x, I've changed it into brackets. And now for -1, I can just type -1 inside the brackets. So we've got 5. So it's -1, 5. Then for 1, just change the number inside the brackets. And that's 1. For 2, we'll write 2 inside the brackets. And that's 2. And for 4, we'll change the number inside the brackets to 4. You can probably spot the symmetry, the pattern now. That's 10. So I've got 10, 10, 5, 5, 2, 2, and a 1 in the middle. It's going to make this shape. It's a quadratic. That's what we want. So this looks correct. So we've got -2, 10, -1, 5, 0, 2, 1, 1, 2, 2, 3, 5, and 4, 10. And we're just going to join them up with a curve. Not straight lines, because it's a quadratic graph. It's a curve. It's not made up of straight lines. So a graph something like that. And then there's a part C. Use your graph to find estimates of the solutions of the equation. X squared minus 2x plus 2 equals 4. So we had y equals x squared. Our graph is y equals x squared minus 2x plus 2. So we can see that y has been changed into 4. So we want to know where y equals 4. Where y is equal to 4. So y is equal to 4 anywhere along the line, y equals 4. So what are the x coordinates here? What are our x coordinates? And we just read them off the graph. We've got minus 0.7 and 2.7. So x equals minus 0.7 and 2.7. You might get something slightly different. You might get 2.8. This one actually looks like 2.8. But as long as you're reading off your graph, you should be okay. Okay, one for you to try. So pause the video and give this a go. So complete the table of values for y equals 2x plus 6 minus x squared. Again, it's a quadratic graph, but this time the x squared's negative. So instead of making a U shape, it's going to make more of an N shape. Same thing as last time. We can use the calculator. Just change the x's into brackets and substitute the x coordinate in to get the y coordinate out. So 2 brackets plus 6 minus brackets squared. So for -2, change the number inside the brackets to -2. So -2 gives us -2, 0, is 6, 1, 7, 3, 3, and 4. It should be -2, looking at the symmetry. 4, -2. So we can plot these on. So -2, -2, -1, 3, 0, 6, 1, 7, 2, 6, 3, 3, and 4, -2. And again, joining them up with a curve. So we have a curve something like that. Use your graph to find estimates of the solutions of the equation 2x plus 6 minus x squared equals 0. They're the roots of the equation. That's where it crosses the x-axis, where y is equal to 0. So we can just read off our x coordinates. I've got minus 1.7 and 3.7. If you're asked for a turning point, remember it's the point where the curve starts turning. So the turning point for this graph is at 1, 7. If you're asked for the roots, it's where it crosses the x-axis. Question 3. Use your calculator to work out the square root of sine 25 plus sine 40 all over cos 25 minus cos 40. Write down all the figures on your calculator display. So we're just going to type this into the calculator. So the square root button first, then the fraction button. So sine 25 plus sine 40 over cos 25 minus cos 40. We don't have to worry about the degrees sign. These angles are measured in degrees. The calculator knows that. So press equals, and we get 2.7560 3957. Part B, write your answer to part A, correct to 2 decimal places. So after the decimal point 1, 2, the next number's the 6, so we round up 2.76. Okay, one for you to try. Give this a go. So use your calculator to work out the square root of tan 20 plus sine 25 all over tan 25 minus sine 20. So square root fraction, tan 20, close the bracket, plus sine 25, close the bracket, over tan 25, and close the bracket, minus sine 20. So we have 2.5170. Five one five 70 6913. And write your answer correct to 2 decimal places. So it's a 5, so it rounds up 2.52. So the next number after 2 decimal places is 5 or above, so we round up. Question 4. Work out 3.42 times 10 to the power of negative 7 divided by 7.5 times 10 to the power of negative 6. Give your answer in standard form. So what you shouldn't do is just write 3.42 times 10 to the power of negative 7 and then divided 7.5 times 10 to the power of negative 6. This won't work because the calculator will want to do it in order. It won't see these as 2 different numbers. So if you're going to type it in like that, you have to put brackets around the 2 numbers like there are in the question. And that will give you your answer, 0.0456. There's an easier way though, because there's a standard form button. So we can type 3.42 and then the standard form button, negative 7, divided by 7.5, standard form button, negative 6. So when we're using the standard form button, the calculator sees these as 2 different numbers and therefore it divides them. So 0.0456. But we need to give our answer in standard form. This is not in standard form. It needs to be a number between 1 and 10, which will be 4.56, then times 10 to a power. So 4.56 divided by 10, 2 times, makes 0.0456. So the power is a negative 2. If we're dividing, the power is a negative 2. It's always times 10 to a power. Then if you want to divide, the power is negative. And we can check the answer on the calculator. 4.56 times 10 to the power of negative 2. Press equals, and it will go back to our decimal form. Okay, one for you to try. So give this a go. We've got work out 2.16 times 10 to the power of negative 5 divided by 2.5 times 10 to the power of negative 4. We need to give the answer in standard form. So we're just going to type this in the calculator. 2.16 times 10 to the power of negative 5 divided by 2.5 times 10 to the power of negative 4. 0.0864. But we need to write it in standard form. So a number between 1 and 10 times 10 to a power. We need to divide by 10 2 times. So the power is negative 2. And again, you could check that. 8.64 times 10 to the power of negative 2 takes you back to the decimal form. Question 5. The density of apple juice is 1.05 grams per centimeter cubed. The density of fruit syrup is 1.4 grams per centimeter cubed. The density of carbonated water is 0.99 grams per centimeter cubed. 25 centimeters cubed of apple juice are mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with a volume 320 centimeters cubed. Work out the density of the drink. So we need to remember that density is equal to mass over volume. And when we're mixing different drinks together, different things together, the total density is going to be the total mass divided by the total volume. So we're going to have to work out the total mass and divide it by the total volume. So for each of our parts, we've got the density and the volume. We don't have the mass. So we can work out the mass of each of these. If you times both sides by volume, you get mass is density times volume. So let's do that for apple juice. Mass is density times volume. 1.05 times 25 is 26.25. So that's the apple juice's mass. For the fruit syrup, the mass is 1.4 times 15. And that is 21. So the apple juice weighs 26.25 grams. The fruit syrup weighs 21 grams. The carbonated water, the mass is 0.99 times 280. And that is 277.2 grams. So now we can work out the total mass by adding the masses together. So 26.25 and 21 and 277.2. So they add up to 324.45 grams. So then we can do the density, which is mass, divided by volume. The total volume, 320. And that gives us, to two decimal places, 1.01. 1.01 grams per centimetre cubed. Okay, one for you to try, so pause the video and give it a go. We have the density of orange cordial is 1.21 grams per centimetre cubed. The density of carbonated water is 1.01 grams per centimetre cubed. A drink with volume 280 centimetres cubed is made by mixing 1 part orange cordial with 7 parts carbonated water. Work out the density of the drink. So again, we've got density equals mass over volume. And for the combined drink, the density is going to be the total mass divided by the total volume. We can work out, we're going to have to work out the mass of both parts. But firstly, we're going to have to use this ratio to find the volume of both of the parts. So 1 part to 7 parts. That means there are 8 parts in total. 280, which is the total volume, divided by 8, means that each part is 35 centimeters cubed. So it's 35 centimeters cubed of orange, and 7 times that, 245 centimeters cubed of carbonated water. So we need to work out the total mass. We've got the total volume, so we're going to work out the mass of orange cordial. So for orange, we've got the density and the volume. The mass is going to be density times volume. So that is 1.21 times 35. And that's 42.35 grams. And for carbonated water, again, mass is density times volume. It's 1.01 times 245, which is 247.45. So our total mass is 42.35 plus 247.45, which is 289.8. And so density is total mass divided by total volume, 280, and that is 1.035. 1.035 grams per centimeter cubed. Question 6. Here is a right angle triangle. So we've got the two short sides, 8 millimeters and 10 millimeters. We don't know the hypotenuse. And we've got a shaded shape made from two of these triangles. And we need to work out the perimeter of this shaded shape. So the first thing we're going to have to do is work out the hypotenuse. So we're going to have to work out the hypotenuse, and we do that using Pythagoras. Pythagoras' theorem. So Pythagoras' theorem says a squared plus b squared is equal to c squared. The two short sides squared and added together equals the hypotenuse squared. So 8 squared and 10 squared makes 164. So the hypotenuse squared is 164. So square root that, and we get the hypotenuse, which is 12.81 millimeters. So 12.81 millimeters. So that's a hypotenuse. But we don't have, we've got a short length here we don't have. So we've got a 10, an 8, an 8, a 12.8, and this short length here. So that is, it's a 12.81, the whole hypotenuse, 12.81, take away this length here, which is a 10. So 12.81 take away 10 is 2.81. So this length here, this short length here, is 2.81 millimeters. So now we've got all the lengths, we can add them together. So we have 2 8s, a 10, a 2.81, and a 12.81. So if we just add all of those together, 2 8s, a 10, and a 2.81, added on to the hypotenuse, we get 41.6. 41.6 millimeters is the perimeter. Okay, one for you to try. So give this one a go. We have ABC is a right-angled triangle. The point D lies on the line A to C. A to B is 9 centimeters. B to D is 13 centimeters. And C to D is 4 centimeters. Work out the perimeter of the triangle ABC. Give your answer correct to 3 significant figures. So we need to work out the missing lengths. Again, we're going to use Pythagoras. So we can use the triangle ABD to work out the length A to D. So the right angle triangle ABD will give us a length AD. So let's call this missing length here X. So Pythagoras tells us that the two short sides squared added together equals the long side squared. So we can get x squared by itself by taking 9 squared away from both sides. 13 squared minus 9 squared is 88. So x squared is 88. So x is the square root of 88, which we can leave as 2 root 22 or 9.38. All right, 9.38. So x is 9.38. We can then find the length B to C using Pythagoras again, but for the big triangle ABC. So we've got 9 centimeters. We've got 9.38 plus 4, which is 13.38. And we've got the hypotenuse. So the two short sides squared added together is equal to the hypotenuse squared. So this one squared plus 9 squared is 260. The hypotenuse squared is 260. So square root the answer, 16.12, I think that was, 13. So 16.126, all right. So the perimeter is 16.1 plus 13.38 plus 9 and that gives us 38.5. So we've got 38.5 centimeters. Question 7. A number m is rounded to 1 decimal place. The result is 2.7. Complete the error interval for m. So we have a number that's been rounded to 2.7. The one up would be 2.8. The one down to 1 decimal place would be 2.6. So to be rounded to 2.7, it must be between these two midpoints. So between 2.65 and 2.75. So it's between 2.65 and 2.75. It can equal 2.65, but it has to be less than 2.75. Okay, one for you to try. So pause the video and give it a go. So this time our number has been rounded to 1 decimal place to 9.4. So it's 9.4 to 1 decimal place. So one up is 9.5. The one down is now 9.3. So it must be between the two midpoints, which is 9.35 and 9.45. Question 8. ABC is a right-angled triangle. We need to calculate the length of AB to 2 decimal places. So we've got a right-angled triangle here. This time we haven't got the 2 lengths and we're finding another one. So it's not Pythagoras, it's SOHCAHTOA. We're finding a length from another length and an angle. There's an angle involved in the question, so it's SOHCAHTOA. We're calculating A to B, so this one is the one we're working out. Let's label the triangle. So opposite the angle is called the opposite. The longest side, which is opposite the right angle, is the hypotenuse. And in between the angle and the right angle is called the adjacent. So which ratio are we using? Are we using SOH, CA, or TOA? So X is in the question, that's O. We've got 12 here, that's A. This H is not in the question, so we don't want H. We want the one with O and A, which is tan, TOA. And TOA means that tan of the angle is equal to the opposite divided by the adjacent. So substituting in what we've got, the angle is 38. So it's tan 38 is equal to O, which is our X, that's what we're working out, divided by the adjacent, which is 12. To get X by itself, multiply both sides by 12. So 12 times tan 38 will give us X. So just type in 12 tan 38 and to 2 decimal places, 9.38. 9.38 centimeters. Okay, one for you to try. So pause the video and give it a go. So again, ABC, a right-angled triangle. Calculate the length of AB. That's this one here. So label the triangle. Opposite the angle is called the opposite. The longest side is called the hypotenuse. They're the 2 in the question. We don't want the adjacent. So we want SOH. We don't want the ones with A in. So we're using SOH, which means sine of the angle, sine theta, is equal to the opposite divided by the hypotenuse. The angle is 38, so sine 38 equals X divided by 16. To get X by itself, times both sides by 16. So 16 times sine 38 is equal to X. And that is 9.85. So X is equal to 9.85 centimeters. Question 9. Aisha recorded the heights in centimeters of some girls. She used her results to work out the information in this table. So we've got the least height, the lower quartile, the interquartile range, the median, and the range. And then it says Aisha drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things Aisha should do to make the box plot correct. So what are the mistakes? So the least height should be 142, but it's been drawn at 144. So the least height should be at 142, not 144. And we've got the lower quartile at 154. That seems to be correct. The interquartile range is 17. So the upper quartile is 154 plus 17, which is 171. And that's not correct. So the upper quartile should be at 171, not 174. And then we've already got 2, so the median, well, the median should be at 162. The median's not correct either. The median should be at 162. And the range is correct. 142 plus 40, so the highest value should be 182, which is correct. So we could have said the least height, the upper quartile, and we could have also said that the median is wrong. Okay, here's one for you to try. So pause the video and give it a go. Holly recorded the heights in centimeters of some girls. So the same question. And what is wrong with the box plot that Holly has drawn? So let's check these. So the least height, 144. That's correct. The interquartile range, let's skip to the median. The median is at 161. So we've got the upper quartile at 174. And we can work out the lower quartile. The upper quartile is correct at 174. So we can work out the lower quartile by taking 19 away from the upper quartile. So it should be at 155. So it's not correct. So the lower quartile should be at 155. The lower quartile should be there. The range is 42. So 144 and 42 make 186. And the highest value has been drawn at 185. So the highest height should be 186. Should be there. Question 10. A group of people went to a restaurant. Each person chose one starter and one main course. So we've got soup or prawns for starter and lasagna or curry for the main. The number of people who chose soup to the number of people who chose prawns is 2 to 3. So I'm just going to change these to fractions, 2 to 3. So there's 5 parts. So 2/5 soup and 3/5 prawns. Of those who chose soup, the number that chose lasagna to the number that chose curry is 5 to 3. So 5/8. This is just of soup, 5/8 and 3/8. And for those that chose prawns, lasagna to curry is 1 to 5. So 1/6 and 5/6. So which fraction of people chose curry? So this is a bit like a tree diagram question. So we've got soup and prawns, and then lasagna or curry. So 2/5 soup, 3/5 prawns. Of those that chose soup, 5/8 lasagna, 3/8 curry. Of those that chose prawns, 1/6 lasagna, 5/6 curry. So the curry in total is soup curry plus prawns curry. So the chance of someone being soup curry is 2/5 times 3/8. And the chance of prawns curry is 3/5 times 5/6. So 2/5 times 3/8 is 3/20. So 3/20 were soup then curry, and 3/5 times 5/6. Half of the people chose prawns and curry. So which fraction chose curry in total? Let's add those two together. 3/20 plus 1/2 is going to be 13/20. So 3/20 plus 1/2, 13/20. And one for you to try. So pause the video and give it a go. So a group of people did a test. The number of children who took the test to the number of adults who took the test was 3 to 5. So there's 8 parts. So 3/8 of the people were children and 5/8 of the people were adults. The number of children who passed to the number of children who failed was 4 to 1. So 4/5 of children passed and 1/5 failed. The number of adults who passed to the number of failed was 7 to 2. So 7 out of 9, 7/9 of adults passed. So what fraction passed the test in total? So 4/5 of the children. So 4/5 of 3/8 passed. So 4/5 of 3/8, which is 3/10. So that's 3/10 of the people in total. And for the adults, it's 7/9 of 5/8. So 7/9 of 5/8 is 35/72. So we've got these people and these people. To get a total fraction that passed, we need to add them together. So 35/72 plus 3/10 is 283/360. So 283/360. That's the fraction of all the people that passed the test. Question 11. Yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. There are only 3 cleaners to clean all the rooms today. Each cleaner is paid £8.20 per hour, or part of an hour they work. How much will each cleaner be paid today? So this is inverse proportion. The more cleaners you have, the less time it takes. So we can multiply these two numbers together. 5 times 4.5. 5 times 4.5 is 22.5. So there's 22.5 hours of work needed. It would take one cleaner 22.5 hours. But we've got 3 cleaners, so we can share that work, 22.5, between the 3 cleaners, and that's 7.5. 7.5 hours per cleaner. And they're going to be paid £8.20 for each hour or part of an hour they work. So they're working 7.5 hours. So they're going to get paid for 8 hours. So it's 8 times £8.20. So they will each be paid £65.60. One for you to try, so give this a go. So it took 7 cleaners 3 hours and 20 minutes to clean all the rooms. So 7 times 3 hours 20 minutes. 20 minutes is a third of an hour. So 3 plus 1/3, 3 and a third is 10 thirds. So we've got 7 cleaners, 10 thirds hours, 10 over 3 hours. So times 7, 23.3 recurring hours of work. So 23.3 recurring hours. So 7 times 3 and a third. That's for one cleaner. That's how long it would take one cleaner. We've got 4 cleaners, so we can share that out between 4, and it's 5.83. 5.83 recurring hours each. If we press the time button, we can find that's 5 hours and 50 minutes, but it doesn't matter because they're paid £11.50 for each hour or part of an hour, so they're going to be paid for 6 hours. So it's 6 times £11.50, and that's 69. So £69 for each of the cleaners. Question 12. Sakura invested £3,550 in a savings account for 3 years. She was paid 2.6% per annum compound interest for the first 2 years and paid R% interest for the third year. She had £3,819.21 in her savings account. At the end of 3 years, work out the value of R. So to add on 2.6%, we times by 1.026. So it's 100% plus 2.6%. So at the end of each year, you get 102.6%. So to calculate 102.6%, you multiply by that as a decimal. So we've got 3,550 to start with. Then we add on 2.6% twice, so for 2 years, so squared. And then we multiply by something in the third year, but we don't know what it is. And that gives us £3,819.21. So we can work out what this multiplier is, and then that will tell us what R is. So 3,550 times 1.026 squared. So after 2 years, she would have had 3,736, and so on. And then that times X is £3,819.21. So to get X by itself, divide by this. So £3,819.21p divided by that answer. So our X is 1.022. So X must be 1.022. So what's that percentage? What percentage increase is that? So 1.022 is 102.2%. So the interest, what's been added on, must be 2.2%. One for you to try, so pause the video and give it a go. So Megan invested £17,500 in a savings account for 3 years. She was paid 3.9% for the first 2 years and R for the third year, and she's got £19,307.23 at the end of 3 years. What is R? So she started with 7,500. We add on 3.9%. So that's multiplied by 1.039 for 2 years. And then another multiplier for the third year. And that equals £19,307.23. So let's get x by itself by dividing by this number. So this is just a number. All of this together, we can just say is one number. And at the moment it's times by x. So to get x by itself, we can divide by it. So I've got £19,307.23 divided by 17,500 times 1.039 squared. So that's 1.022. So x is 1.022. So that's the multiplier. So 1.022 is 102.2%. So R is 2.2%. Question 13. Enlarge the shaded shape by scale factor -2 with a center of enlargement at 0, 0. So we are going to see how far we have to go from our center of enlargement to get to each point. So to get to this purple point here, it's back 3, down 2. So back 3, down 2. And the scale factor is -2. So we're going to multiply that distance by -2. So where would we be now? So -3 times -2. A negative times a negative is a positive. 3 2s are 6. A negative times a negative is a positive. And 2 2s are 4. So the purple point is now at 6, 4. It's now over here. This red point here is 2 left, 4 down. So -2, -4. If I times that by -2, I go to 4, 8. So the red point is now at 4, 8. This green point here is back 5, down 2. -5, -2. The scale factor is -2, so multiply that distance by -2, and that's 10, 4. 10, 4. And one more. So I have a yellow point. Back 6, down 4. Times -2 will be 12, 8. 12, 8. So if we just join all those points up, we get our new shape. And we can check that it's an enlargement. If it's an enlargement, if you join up through the center of enlargement, you should get to the other points. So there's the green point, the yellow point, the red point, and the purple point all go through the center of enlargement. Okay, one for you. So enlarge the shaded shape by scale factor -2 again. If the scale factor was different, you'll just be multiplying by a different number. Center of enlargement is at 0, 0 again. So to get to this corner, back 2 down 2, times by the scale factor. So that point is now at 4, 4. This blue point, back 5 down 2, times by the scale factor. That's 10, 4. This purple point, back 3 down 4, times by the scale factor. That's 6, 8. And this yellow point, back 6, down 4, times by the scale factor. That's 12, 8. So just join up the points, and there is our new shape. Question 14a. Write 4x squared minus 9 over 6x plus 9 times by 2x over x squared minus 3x in the form ax plus b over cx plus d, where a, b, c, and d are integers, whole numbers. So this is simplifying an algebraic fraction. To do that, we're going to, times fractions together, we just times the top times the bottom. But we're also going to be factorizing all of these so we can cancel out anything that's common to the top and the bottom. So 4x squared minus 9 is the difference of two squares. They're both square numbers. So it's 2 brackets, and it's 2x plus 3 and 2x minus 3. 6x plus 9 is a single bracket. Take 3 outside, and we've got 2x plus 3 in the brackets. That's times by 2x over, and again factorizing x squared minus 3x. Take x on the outside, and we've got x minus 3 inside. So times the top times the bottom. We'll do that first, and then we'll cancel out after. So 2x times 2x plus 3 times 2x minus 3 on the top, and 3x times 2x plus 3 times x minus 3 on the bottom. So what's common? They've both got a 2x plus 3. They've both got an x. So what have we got left? We've got 2 times 2x minus 3 on the top, 3 times x minus 3 on the bottom. It's not quite in the form we wanted. We need to expand the brackets. So 2 times 2x is 4x. 2 negative 3s are negative 6. 3 times x is 3x. 3 negative 3s are negative 9. And now it's in the form we wanted. So that is our answer. Okay, one for you to try. So give this a go. So it says write x cubed minus 4x over 3x minus 6 divided by x squared minus x over 5. So when we're dividing fractions, dividing a fraction is the same as timesing by its reciprocal. So we can change it into a times question by flipping over the second fraction. And then let's factorize whatever we can. So x cubed minus 4x, I can take x outside, and that leaves x squared minus 4 inside, which I can factorize again, the difference of two squares. 3x minus 6, I can take 3 on the outside, have x minus 2, and x squared minus x, I can take x outside and have x minus 1. So let's times these together. So 5x times x squared minus 4. I'm going to rewrite x squared minus 4 as x plus 2 times x minus 2. I've got 3x on the bottom times x minus 2 times x minus 1. So cancel out what's common. They've both got x minus 2. They've both got an x. So I've got 5 times x plus 2 on the top. So I'm going to expand that. 5x plus 10. And I've got 3 times x minus 1 on the bottom. So 3x minus 3. (14b). Express 3 over x plus 1 plus 1 over x minus 2 minus 4 over x as a single fraction in its simplest form. To add fractions or take fractions away, we need to make the denominators the same. So we can make the denominator x times x plus 1 times x minus 2. And whatever we multiply the bottom by, we have to multiply the top by the same thing. So we're going to have x times x plus 1 times x minus 2 on the bottom. For the first fraction, that means I'm timesing the bottom by x and x minus 2. So I have to times the top by x and x minus 2. For the second fraction, I'm timesing the bottom by x and x plus 1. So I times the top by x and x plus 1. And for the last fraction, I'm timesing the bottom by x plus 1 and x minus 2. So I times the top by x plus 1 and x minus 2. So now I've got a common denominator. All the denominators are the same, so I can make them one fraction. So I can make it one big fraction, 3x times x minus 2 plus x times x plus 1 minus 4 times x plus 1 times x minus 2, all as one fraction over x times x plus 1 times x minus 2. So it's a single fraction. It's not in its simplest form. I can expand and simplify this top line. So 3x times x, 3x squared. 3x times negative 2, negative 6x. X times x is x squared. X times 1 is x. I'll keep the minus 4 here, and I'll put the bracket while I expand these two brackets. I have to remember to take away all of this, not just the first term. So x times x is x squared. X times negative 2 is minus 2x. 1x is x, and 1 negative 2 is negative 2. So I'll keep my denominator. So then I'll expand this bracket, and then I'll collect the like terms. I can collect some like terms as I go though. I'll do that. So 3x squared and x squared make 4x squareds. Minus 6x plus an x is minus 5x. That's as much as I can do. So I've got minus 4 times x squared, which is minus 4x squared. Minus 4 times minus 2 is plus 8x. Minus 4 times x minus 4x. minus 4 times minus 2 plus 8. And the denominator is still the same. So collecting the like terms, again on the top I've got 4x squared, take away 4x squared, that's nothing. I've got 8x minus 5x minus 4x, which is minus 1x, and I've got an 8. So I've got minus x plus 8, or 8 minus x, over x times x plus 1 times x minus 2. There's nothing more I can do to simplify it, so that is the answer. One for you to try, so pause the video and give this one a go. So we have 3 over x minus 1 plus 2x over x minus 2 minus 2. And we need to write it as a single fraction in its simplest form. So we need to make the denominators the same. To add fractions, we need to make the denominators the same. So the denominator is going to be x minus 1 times x minus 2. So for the first fraction, we're going to have 3. If we multiply the bottom by x minus 2, we have to multiply the top by x minus 2. For the second one, we have to multiply the bottom by x minus 1. So we times the top by x minus 1. And for the 2, we have to multiply the top and the bottom by x minus 1 and x minus 2. So we're going to have 2 times x minus 1 times x minus 2 over x minus 1 times x minus 2. Now the denominators are the same, we can write it as a single fraction. So we've got 3 times x minus 2 plus 2x times x minus 1 minus 2 times x minus 1 times x minus 2 all over x minus 1 times x minus 2. So we can expand and simplify the top line. So 3 times x is 3x. 3 times negative 2 minus 6 plus 2x times x is 2x squared. 2x times minus 1 minus 2x. I'm going to leave the minus 2 here because we need to take away all of this and expand these brackets. So x squared minus 2x minus x plus 2. And I'm going to leave the denominator as it is. So I'll collect what I can. There's not much I can collect. So I've got 2x squared. I've got 3x minus 2x, which is just 1x, and minus 6. I can't do anything else because this is all multiplied together. I can expand this bracket though. Minus 2 times x squared minus 2x squared. Minus 2 times minus 2x plus 4x. Negative 2 times negative x plus 2x. Negative 2 times 2, negative 4. And leave the denominator as it is again. And collecting the like terms, 2x squared take away 2x squared is nothing. I've got x and another 4x and another 2x. So that's 7x's. Minus 6 minus 4 is minus 10. So 7x minus 10 over x minus 1 times x minus 2. Question 15. Use the iteration formula xn plus 1 equals the cube root of 10 minus 2xn to find the values of x1, x2, and x3, starting with x0 equals 2. So an iteration formula, so we can find x1 by doing the cube root of 10 minus 2 times x0. And x0 is 2. So we can just type that into the calculator to find x1. We can even write 2, press equals, so we can use our ANS button. So we've got the cube root of 10 minus 2 times the answer, which is 2. Press equals, and we get x1, 1.8171. 1.8171. Then we find x2 by substituting 1.8171 in here, into where our answer is. So our calculator is going to take this number and use it as ANS. So I just press equals again, 1.8533. So x2 is 1.8533. And then we want to substitute 1.8533 in, which we can do by just pressing equals again, 1.8463. And that is the answer. We've got x1, x2, and x3. The values x1, x2, and x3 are estimates of the solution of an equation of the form x cubed plus ax plus b equals 0. Find the value of a and the value of b. So what we can do is we can take our iteration formula, but get rid of these n plus 1s and n. So just write x equals the cube root of 10 minus 2x. So just get rid of the n plus 1 and the n, and then we can just rearrange it. So to get rid of the cube root, we can cube. So cube both sides. X cubed is 10 minus 2x. And then make it equal to 0, so plus 2x. And take away 10. So what's a and b? This is the equation. What's a and b? A is 2, and b is negative 10. One for you to try, so pause the video and give it a go. So use the iteration formula. So xn plus 1 is the cube root of 8 minus 3xn. And again, we're starting with x0 is 2. So to find x1, we're going to substitute in 2. To find x2, we'll substitute in our answer for x1. And to find x3, we'll substitute in our answer for x2. So x1 is the cube root of 8 minus 3 2's. So press 2 so we can use the ANS button. Then the cube root of 8 minus 3 answers. So 1.2599. x2, 1.6160, and x3, 1.4662. The values of x1, x2, and x3 are estimates for the solution of an equation. What's the equation? So take the iteration formula again and rearrange it. So to get rid of the cube root, we cube and then make it equal to 0. So x cubed plus 3x minus 8 equals 0. So a is 3, b is negative 8. Question 16. Here is a speed time graph for a car. Part A, work out an estimate for the distance the car travelled in the first 30 seconds. So when we've got a speed time graph, the distance travelled is the area under the graph. So in the first 30 seconds, we could just draw a triangle. And work out the area of the triangle. So the area of a triangle is half times the base, which is 30, times the height. So there's 5 little boxes between 8 and 10. So each one is 0.4. So this must be 8.8. So 8.8 tall. So half times 30 times 8.8, and that's 132. So 132 meters. Is your answer to part A an underestimate or an overestimate of the actual distance? It's an underestimate because there's an area, a small area in between the triangle and the curve that's not included. So give a reason for your answer. The total area under the curve is not included in the triangle. There's a green bit missing. Julian used the graph to answer this question. Work out an estimate for the acceleration of the car at time 60 seconds. So the acceleration at this point. The acceleration on a speed time graph is the gradient. So the acceleration at 60 seconds is the gradient at that point. So the gradient of the tangent at that point. His working out is acceleration is speed over time, and that's 13 divided by 60. Julian's method does not give a good estimate. At time 60 seconds, explain why. So Julian has worked out the acceleration of this line. So we can just say he should have drawn a tangent. He should draw a tangent. I guess what he's worked out is the average acceleration in the first 60 seconds, not the acceleration at time 60 seconds. He should have drawn a tangent at time at t equals 60. Okay, one for you to try. So pause the video and give it a go. So here is a speed time graph. Work out an estimate for the distance the car travelled in the first 30 seconds again. So we can draw a triangle. If we wanted to work out a bigger distance, if we wanted to work out the first 60 seconds, we could have a triangle and a trapezium. But this is just the first 30 seconds. So half times the base times the height, which looks like 9.2. So half times 30 times 9.2 is 138 meters. Work out an estimate for the acceleration at time 45 seconds. So the acceleration is the gradient. So we'll draw a tangent at 45 seconds. So around there. Let's find 2 points and work out the gradient. So 4512 is 1 point. So 4512 and 3010 seems to be a point. So we'll have change in y over change in x. So we can call these x1, y1, x2, y2, or even the other way around. So that the change in y's, so the gradient is the change in y's. So 12 take away 10, or 10 take away 12, over the change in x's, 45 take away 30. So that's 2/15. So it's 2/15 meters per second squared. Meters per second per second. 2/15, and that's 0.13 recurring, so something around there should be good for that mark. Question 17. Here are the first 5 terms of a sequence. Find an expression in terms of n for the nth term of this sequence. So it's a quadratic sequence, and we can tell that because it goes up 1, 3, then 5, then 7. So the second difference is 2. In a quadratic sequence, the second difference is the same. So not the first difference, the difference between the numbers, the difference between the differences. So a quadratic sequence is in the form something n squared plus something n plus something. An squared plus bn plus c. I am going to use, I've memorized that this number is 2a. This number here is 3a plus a b, and this number here is a plus b plus c. So I'll use those to work out what a, b, and c are. So 2a's equal 2. That means a must be 1. So it's 1n squared. 3a's plus a b equal 1. So 3 1's plus b equal 1. 3 plus b is 1. B must be negative 2. So 1n squared minus 2n. Then a plus b plus c is negative 1. So 1 minus 2 plus c is negative 1. That's minus 1 plus c is minus 1. So c is 0. So I've got 1n squared minus 2n plus 0. N squared minus 2n. And we can check that by substituting the numbers in. So n squared minus 2n. So the fifth term is when n is 5. So that should be 15. And it is. The first term should be negative 1. And it is. So it's n squared minus 2n's. One for you to try. So let's look at the first difference. So it's going up 3, 7, 11, 15. So the second difference is the same. So it's a quadratic sequence. An squared plus bn plus c. So 4 is 2a's. The 3 is worth 3a's plus a b. And the negative 4 is a plus b plus c. So 2a's are 4. That means a is 2. So it's 2n squared. 3a plus b is 3. 3 2's plus b is 3. 6 plus b is 3. B is negative 3. And a plus b plus c is negative 4. 2 minus 3 plus c is negative 4. Negative 1 plus c is negative 4. C must be negative 3. So that means I've got 2n squared minus 3n minus 3. And again, I'll check my answer. So 2, the fifth term should be 32. So 2 times 5 squared minus 3 fives minus 3 is 32. So that's my nth term. Question 18. ABC and ADC are triangles. The area of ADC is 56 meters squared. Work out the length of AB. Give your answer correct to 1 decimal place. So we're going to use the area of this triangle. So we're going to use the formula area is half AB sine C. So the area of any triangle is half AB sine C. We can use that to find the length, I'll call it YCD. Then we can use the cosine rule to find, I'll call this one Z, A to C. And then we can use the sine rule to find X. So we're going to use the area of any triangle and the cosine rule and the sine rule all in this one question. So the area, 56, is half times 11 times y sine with the angle 105. So to get y by itself, divide by half times 11 times sine 105. So y is 56 over half times 11 sine 105. So we've got 10.54. So y is 10.54. So that's this length here. Then we can use the cosine rule. The cosine rule, like the area, we use when we've got an angle and 2 lengths on either side of it, and we're finding the opposite length. Or we could also use the cosine rule when we've got all 3 lengths and we want to find out an angle. So this is the cosine rule. So that's a squared equals b squared plus c squared minus 2bc cos a. So if this is big A, this is our angle, that's big A. Opposite it is little a, and the other two in any order are B and C. So we have z squared equals 11 squared plus 10.54 squared minus 2 times 11 times 10.54 cos 105. So 11 squared plus answer squared minus 2 times 11 times answer cos 105. So 292 and so on. So z squared is 292 point something. So square root of that, 17.09. So z is 17.09 centimeters. So now we know this length, we can use the sine rule. So we've got opposites. Z is opposite 118. X is opposite 48. So the sine rule says A over sine A is equal to B over sine B. So if we keep this as little a, this one's big A, this is little b, this is big B. The angles are always the big letters, and big A is opposite little a, big B is opposite little b. So we have 17.09 over sine 118 is equal to x over sine 48. To get x by itself, at the moment it's divided by sine 48. So we do the opposite, and that's timesing by sine 48. So x is 17.09 over sine 118 times sine 48. So that's answer over sine 118 times sine 48. So to one decimal place, 14.4. So x is equal to 14.4 meters. And one for you to try. So pause the video and give it a go. So ABC and ADC are triangles. We've got the area of ADC as 58 meters squared. We need to find AB to one decimal place. So we're going to use the area to find CD, then the cosine rule to find AC, and then the sine rule, because we've got opposites, to find AB, to find X. So firstly, area is half AB sine C. So 58 is half times 12 times y sine 102. So we can get y on itself, y by itself, by dividing by half times 12 times sine 102. So y is 58 divided by half times 12 times sine 102. 58 over half times 12 times sine 102. So 9.88. We've got 9.88 here. Then we can use the cosine rule. Big A, little a, and B and C. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. So z squared is 12 squared plus 9.88 squared minus 2 times 12 times 9.88 cos 102. So typing that in the calculator, 12 squared plus answer squared minus 2 times 12 times answer cos 102. So 291. So z squared is 291. Square root that, 17.06. So z is 17.06. That's this one. Now we've got opposites, so we can use the sine rule. So little a opposite big A, little b opposite big B. So b over sine B is equal to a over sine A. So x over sine 51 equals 17.06 over sine 112. To get x by itself, we'll multiply both sides by sine 51. So 17.06 over sine 112 times sine 51. So answer over sine 112 times sine 51 gives us x, 14.3. 14.3 meters. Question 19. A, B, and C are three spheres. The volume of sphere A is 125. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of B to C is 1 to 2. Work out the ratio of the surface area of A to C. So the volume of A to B is 125 to 27. The scale factor for volume is the scale factor for length cubed. So we can find the scale factor for length by cube rooting. So the scale factor for length, cube root 125 is 5, cube root 27 is 3. So the ratio of the radius of A to B is 5 to 3. And the ratio, so that's A to B, and then B to C is 1 to 2. So to make these ratios 1, to get them together, we need the B's to be the same. So if we multiply our second ratio by 3, that will become 3 to 6. So now the B's are the same. We can just write the ratio for lengths of A to B to C. It's 5 to 3 to 6. But we don't want the ratio for lengths. We want the ratio for area. And the ratio for area will be scale factor squared. So we just need to square this. So the scale factor for area is A to B to C, 25 to 9 to 36. And the ratio of A to C we want, so it's 25 to 36. One for you to try. So give this one a go. So A, B, and C are three spheres. We've got the surface areas this time, 25 to 36. So A to B for surface area is 25 to 36. For lengths, we've got B to C as 2 to 3. And we want the ratio of the volumes. So for length, we have to square root the area scale factor. So that would be 5 to 6. So the ratio of the radiuses, A to B, is 5 to 6. And for B to C, it's 2 to 3. So we want to make the B's the same again. So I want them both to be 6. So times by 3 will give us 6 to 9. So for lengths, for the radius, A to B to C is 5 to 6 to 9. We want the volume, so the scale factor for volume is scale factor cubed. So for the volume, 5 cubed is 125. 6 cubed is 216. And 9 cubed is 729. So the ratio of the volume of A to the volume of C is 125 to 729. Question 20. The histogram gives information about the heights in meters of the trees in a park. The histogram is incomplete, and it says 20% of the trees have a height between 10 and 12.5. So 20% of the trees have a height between 10 and 12.5. So that's missing. And we need to complete the histogram. So what we can do is work out the area of each of the bars. In a histogram, the area gives us the frequency. So 2.5 is the width of the first bar. Its height is 1.2. So 2.5 times 1.2 is 3. So this one's got an area of 3. 2.5 times 2, that would be 5. So the second bar's got an area of 5. 5 times 2.8, that will be 14. So this one's got an area of 14. And the last bar, it's 12.5 wide. Its height is 0.8. 12.5 times 0.8 will be 10. So this must be 80%. So 20% of the trees are missing. So what we have here, 3, 5, 14 and 10. 3 plus 5 plus 14 plus 10 is 32. 32 trees. That's 80% of the trees. So if I divide that by 8, 10% is 4. So 100% is 40. So divide by 8. So 4 trees are 10%. So 20%, the missing trees must be 20%, which should be 8 trees. So we need to draw in 8 trees here. That needs to be 8 trees. So that's the frequency. We know the width is 2.5. So 2.5 times the frequency density must equal 8. The width times the height must equal 8. So to get the frequency density, 8 divided by 2.5, it's 3.2. So it needs to be 3.2 tall. So there is our bar. So it's 8 trees. It's got an area of 8. It's got an area of 8, and that makes it 20%. Okay, one for you to try. So give this one a go. So we've got the histogram. It gives information about the heights of trees again. This time we're told that 12% have a height between 2.5 and 5. Between 2.5 and 5, that's 12%. So let's work out the areas of what we've got. So the area of this bar, this 12%, is 2.5 times 2.4. 2.5 times 2.4 is 6. So 6 trees. So 6 trees are 12%. So each tree must be 2%. Each tree is equal to 2%. So let's work out all of these areas. So 2.5 times 1.6 is 4. So 4 trees is 8%. So double it. 5 times 3.2 so 16 trees, double it, 32%. And the last box, 10 times 1.1, that's 11. So 11 trees, 22%. So what's missing? 100%, take away these. So 8%, 12%, 32%, and 22%. That's 74%. 100, take away 74. Is 26. So 26% must be in here. Each tree is worth 2%. So we've got an area of 13 trees. 13 trees missing. So the class width, 5, times the frequency density times the height must equal 13. 13 over 5 is 2.6. So the bar must be 2.6 tall to have an area of 13. Question 21. There are 12 counters in a bag. There is an equal number of red counters, blue counters, and yellow counters. So there must be 4 of each. So there must be 4 red, 4 blue, and 4 yellow counters in the bag. 3 counters, there are no other counters. 3 counters are taken at random. What's the probability of getting 3 reds? So the chance of getting a red the first time is 4/12. 4 reds out of 12 in total. Then if we took a red one out, there are 3 reds out of 11 in total. And then if we did pick another, if we got 2 reds, what's left? 2 reds out of 10 in total. So the chance of getting red, then red, then red is 4/12 times 3/11 times 2/10. So 1/55. The 3 counters are put back into the bag. Some more counters are now put in the bag. There's still an equal number of red, blue, and yellow, and none of any colour. 3 counters are taken at random. Is it now less likely, equally likely, or more likely that they will, all 3 will be red? So if there's loads and loads and loads of counters, if there's hundreds of each colour, the more you get in, the closer it's going to be to these probabilities staying the same every time. If there's an infinite number of counters, it's going to be a third times a third times a third, which would be 1/27. So it's going to be more likely to get 3 reds because there'll be more reds to pick from, a higher proportion of reds for the following picks. So the proportion of reds for the second and third pick will increase. And one for you to try, so pause the video and give it a go. There are 15 counters in a bag. There's an equal number of red, blue and yellow. So 5 of each. Five red, 5 blue, 5 yellow. 3 counts are taken at random from the bag. Work out the probability of taking one of each colour. So to take one of each colour, we can get red, then blue, then yellow. We can get red, then yellow, then blue. That's if we pick a red first. If we pick a blue first, we can get blue, yellow, red, or blue, red, yellow. And if we pick the yellow first, yellow, red, blue, or yellow, blue, red. So there are 6 possible combinations for doing this. So the probability of getting a red, then a blue, then a yellow is 5/15 for getting the red. And if we take a red out, the chance of getting a blue is 5 out of 14. And then the chance of getting a yellow is 5 out of 13. And that's going to be the same calculation for all of these. It's all going to be 5/15 times 5/14 times 5/13. So 5/15 times 5/14 times 5/13 is 25 over 546. And it's just that 6 times. So there are 6 possible ways of doing that same thing. So 6 times that answer. So if we did it 6 times and then added them all together, it's the same as multiplying it by 6. 25 over 91. Question 22. Solve algebraically the simultaneous equations. So we've got 2x squared minus y squared equals 17 and x minus 2y equals 1. So we've got one linear equation, this bottom one, it's just x's and y's, and we've got one with x squareds and y squareds in it. So we have to solve it using substitution. So we can make our linear one, our bottom one, either x equals or y equals. So if we take away 2y from both sides, we can say x is equal to 1 minus 2y. And then we can substitute that in for x. So we can get rid of x by substituting in 1 minus 2y. So I've got 2 times 1 minus 2y squared minus another y squared equals 17. So squared means times itself. So 1 minus 2y times 1 minus 2y. And now I'm going to expand the brackets. So leave the 2 for now. 1 times 1 is 1. 1 times minus 2y, minus 2y. Minus 2y times 1, minus 2y again. And minus 2y times another minus 2y. And negative times a negative is positive. And 2y times 2y is 4y squared. Let's expand the brackets. So 2, 1 to 2. 2 times negative 2y is negative 4y. 2 times negative 2y is negative 4y again. 2 times 4y squared is 8y squared. And now collect the like terms. So for the y squareds, I've got 8 of them, take away 1 of them. So 7y squareds. Minus 4y minus another 4y is minus 8y. and I've got 2 equals 17. I've got a quadratic. To solve it, I want to make it equal to 0. So take 17 away from both sides. So 7y squared minus 8y minus 15 equals 0. To solve the quadratic, I could use the quadratic formula with a is 7, b is -8, or c is -15. But before I use that, I'm going to check if I can factorize it. So 7 15s are 105. So that's a times c, the first number, times the last number. And then I'll see if anything multiplies to make 105 and adds to make 8. So 105, it's not in the 2 times table. 3 35s, it's not in the 4s, but it's 5 21s. It's not in the 6s. Is it in the 7s? I'm not sure. Yes, 7 15s. And they'll give me an 8. So 7y squared plus 7y minus 15y minus 15 equals 0. So I can rewrite minus 8y as 7y, take away 15y. They are the same, they're equivalent. So I've just split it out into 2 terms. And then I can go from there into double brackets. So what can I take out of the first 2 terms? What's a factor of both of them? They've both got a 7 in and a y. So 7y is my first term. 7y times something is 7y squared. That's y. 7y times something is 7y. That's a 1. Something times y is minus 15y. That must be minus 15. And there it is factorized. So what does it equal? What makes the first bracket 0? 15 over 7. What makes the second bracket 0? -1. And I can find x, because x is 1 minus 2y. So x is 1 minus 2 lots of 15/7. 1 minus 2 times 15/7 is minus 23/7. And 1 minus 2 times -1 is 3. So y equals -1 and x equals 3, or y is 15/7 and x is minus 23/7. Okay, one for you to try. So pause the video and give this a go. So we're going to be solving by substitution. So we're going to make our linear one, our second one, either x equals or y equals. So if I make it y equals, I'll say 2y, if I take 5x away from both sides. 2y is 6 minus 5x. So y is 6 minus 5x over 2. So I can substitute that in for y. I'll change y into 6 minus 5x over 2. So I've got 2x squared plus 6 minus 5x over 2 squared equals 12. So 2x squared plus 6 minus 5x over 2 times 6 minus 5x over 2 equals 12. When we multiply fractions, we times the top and times the bottom. So for the bottom, we've got 2 times 2, which is 4. And for the top, we've got these double brackets to expand. 6 sixes are 36. 6 times negative 5 is negative 30. So 6 times negative 5x is negative 30x. Negative 5x times 6 is negative 30x. And negative times a negative is positive. 5x times 5x is 25x squared. I want to get rid of this divide by 4. So to get rid of a divide by 4, I need to multiply by 4. But if I multiply this by 4, I've got to multiply everything by 4. So that includes this 2x squared as well, and this 12. So that will give me 8x squared plus 36 minus 30x minus another 30x is minus 60x plus 25x squared equals 12 fours, which are 48. I'm now going to collect the like terms. So 8 and 25 x squareds make 33x squareds. I've got minus 60x, and if I take 48 away from both sides, that's minus 12 equals 0. I can simplify this by dividing through by 3. So 11x squared minus 20x minus 4 equals 0. I'll see if I can factorize it first. So 11 fours are 44. 1 44, 2 22s, or 4 11s. I can make a minus 20 out of 2 and 22. So this one will factorize. 11x squared plus 2x minus 22x minus 4 equals 0. So what can I take out of the first two terms? Just an x. So it's an x here. X times something is 11x squared. That's 11x. X times something is 2x. That's 2. And something times 11x is minus 22x. That's negative 2. And negative 2 times positive 2 is negative 4. So that means x is equal. What makes the first bracket 0? 2. What makes the second bracket 0? Minus 2 elevenths. So x is 2, or minus 2 elevenths. Y is 6 minus 5x over 2. So 6 minus 5x over 2. So if x is 2, y is negative 2. So we've got x is 2 and y is negative 2, or x is minus 2 elevenths and y is minus 2 elevenths, 38 elevenths. So there are our answers. And question 23. So D is 1/8 of C cubed, and C is 10.9, correct to 3 significant figures. By considering bounds, work out the value of D to a suitable degree of accuracy. Give a reason for your answer. So we need to know the upper bound and the lower bound for C. So it's 10.9, correct to 3 significant figures. The one up is 11.0. The one down is 10.8. So its lower bound is 10.85. Its upper is 10.95. So the upper D the biggest thing D can be is 1/8 of 10.95 cubed. That's 164.1165. The lower bound is 1/8 times 10.85 cubed. Which is 159.6611. So by considering bounds, work out the value of D to a suitable degree of accuracy. So what do the upper bound and the lower bound agree on? So we can't round them to the nearest whole number because there's 164 and 160, but we can round them to the nearest 10 or two significant figures. They will both be 160. So 160 to two significant figures as upper and lower bound both round to 160 to two significant figures. So our answer is 160. And one for you to try. So pause the video and give it a go. So this time D is 1/5 of C cubed and C is 11.2 to three significant figures. So 11.2, the one up's 11.3, the one down's 11.1. So the lower bound 11.15, the upper bound's 11.25. So our upper bound for D is 1/5 of 11.25 cubed, and the lower bound is 1/5 times 11.15 cubed. So 1/5 times 11.25 cubed is 284.7656. 284.7656, and the lower bound 277.2392. So what do they both agree? 280 to two significant figures as both the upper bound and lower bound round to 280 to two significant figures.